Hey, another draft physics video presentation. Draft science here on YouTube. Anyway, no comments worthy of acknowledgement even. So, I guess we'll just do a summary of what we have learned lately. The last month has been very productive in my opinion in terms of nailing down useful analogies and useful ways to describe how simple the function of electrons, for example, is, and what the basic mechanism is. So I could call this 2 plus 2 plus 2 physics, because there's only two kinds of force and two kinds of matter and two kinds of interactions that happens between force and matter, and that's explains everything we observe in common experiments anyway. The more complex experiments obviously have layers of assumptions built into them about what's happening, what the thing that they're analyzing even is, and those assumptions are deductions. I would argue are often incorrect, imprecise at the minimum. So only partially true, maybe. Anyway, so the universe, everything that happens, is basically happening because the universe is made out of a thing. I would argue that you could view it this way. It's just made out of this stuff, and each one of these little bits, we'll call them quanta, just to make it simple, because it's been quantum mechanicized, and that is correct. Each little bit has momentum. So the whole universe is just grains of sand, however you want to look at it, all moving the speed of light in a straight line. And that's all they do. And what has happened in the past at some point, so if you start with just that, just a bunch of BBs that have energy, and the energy is perpetual in the sense they never stop rowing. We'll call them rowers. They never stop. They just keep going the speed of force in a direction. And the only thing that can happen is essentially, kind of, is they can be in a different arrangement, in the sense that they can join what might be called a row of them. So we could put some in a row and say these are all little fellas, all move in the same dimension, all moving in one dimension. There's no guys going this way or any crooked ways. And then if you put a bunch of that together, in the sense that all these are going in this dimension, and then all these would be going here, and then you can have obviously the in and out dimensions, and they're just all going in these lines. Either this one's going this way or it's going that way. This one's either going this way or that's going that way. And this, essentially, could be described as what an electron is, or a proton. It's just a collection of energy. Now, I think this is going one step further than I need to go in terms of getting it elemental. So, I'm just arguing that you could reduce it all just to the force. And you could just forget about electrons and protons as being solid objects for the sake of an argument. It doesn't have to be that they are actual, what we'll call them, boats, that electrons and protons that force can interact with. So anyway, so it needs to be understood that there's, as stated, two kinds of force bits. So there's force that reacts a certain way with protons, and force that reacts with electrons. So there's two kinds of boat, all right, and there's two kinds of rower, if you want to look at it that way. I think it's a productive way to look at it, but whatever. So the rowers are in the sea. So those are the little bits moving in straight lines and directions, and they're also in the boats. And so when they're in the boat, their direction, okay, as a collective, will be realized. So if there's 3 rowers going this way and 2 rowers going this way, all right, then the boat will have a bias in this direction. So it'll have some direction this way. Now the same is true for all the other rowers in the boat. There's always going to be a direction. So there might be a little bit of direction this way, and there might be a little bit of a direction this way. I mean, obviously dimensionally it has to even out. I mean, you can't screw up the dimensions. So it's best to probably understand it as the 3 dimensions. So it'll have a bias in that direction, and they could have a bias for this dimension in this direction, and let's say it's coming out of the board, so we'll put the dot for it coming out. Okay, and that would be, so its overall movement would be out a little bit this way and a little bit that way, so it would be coming this way. That would be its movement based on what rowers it has in its boat. Now if it hits a new rower going, you know, in this direction, that direction will have a component this way, and it'll have a component against this velocity this way. So now the direction here, one might switch to this direction, and obviously the vector will switch based on what the change in the net velocity. So the only thing that the helpful, I think, thing to understand is that when they're free, they decide where they're going, obviously. And when they're in a boat, it's a collective decision. It's a net decision about what direction the boat is going. So the electron moves based on what force it has absorbed. All right, so I'll clean this up. Do the simple explanation of the 2 matter bits. I shouldn't have to explain, proton and electron. And I'll just explain the 2 interactions, because that's the only part that's really significant. So you have the 2 kinds of force. You know, you got red and black force, and you know, all mixed up. And they have these 2 elemental particles. And the key thing that happens is that when a black one hits a black boat, it jumps in, so it goes into the boat. It becomes part of the calculation of which way the electron will be, and there's an exchange made. So when one jumps in going this way, one jumps out going the opposite way. That happens with electrons when a black rower hits a black boat. When a red rower hits a red boat, the same thing happens, except the only difference, well, don't really need to get into this technical part, but anyway, that there's actually an even number of seats in the proton boat. There's an odd number in the electron boat. So you can understand that the electron could only have, it can never have it's never divisible by 2. So you can never have an even amount of force going one way and going the other way in the boat. It's always an odd number. So the electron always has a bias. It's always going to travel in that direction or that direction, or in that direction or in that direction, or in or out. It's never going to be stationary in any dimension. Where the proton has even numbers, therefore it can have 3 and 3. It can have 3 rowers going this way, 3 rowers going that way, so it can stay in one position. Can. Not just saying it does, just saying it can. So anyway, the same thing happens. It reflects. So the rower jumps in the boat, and he takes the place of a guy going the opposite direction, and that guy leaves. So all interactions are essentially reflections. The force does go back to the source. So any photon that hits something, there's another photon heading back to the source. And we just don't encounter that, because when we see things, we see them based on light projected onto a surface from another angle, and so we never see any of the light going back because it's not visible to us. All right, doesn't ever go back to our eye because our eye doesn't emit light, it receives it. Anyway, so it's just one of those little subtle things that's, you know, kind of hugely important in understanding that that's why there's no fundamental difference between surfaces being reflective and absorptive from our perception, in the sense that one didn't absorb more energy. Alright, so that's another technical point you probably don't need to understand for this purpose, but anyway. Okay, so that's what happens when the same force hits the object. There's a reflection. And you could sort of understand that if it was two objects and they reflect something, and there's another object going to reflect it back, that this reflection would just end up being trapped between them, and that it can just, you know, the closer they get, the more interactions. The further away they get, the less interactions, and the less boat changing, the less momentum changes. And that clearly all the momentum would be in this direction for the object. It would keep, this boat would keep exchanging this way for that way, and this one would keep exchanging that way for this way. And obviously that's pressure, and so you can understand why electrons hate electrons and why protons hate protons. Kind of obvious there. Alright, so now on to the second interaction. So that's the reflection. Common force reflects in kind of an obvious way. Alright, and so what happens when black force hits a proton, let's say? There's a different kind of interaction. There's not a reflection. Through the process of whatever protons are made out of, the black bit will just leave through one of the perpendicular dimensions. So that means it'll go up or down, or it'll go left and right, you know, in or out. But it goes one of those other dimensions. It leaves. So the force isn't reflected. Therefore, the pressure between an electron and a proton can get very low, because all of the black bits, all of the red bits leave the electron perpendicularly, and all of the black swimmers or rowers leave the proton perpendicularly in some perpendicular direction, and therefore no pressure builds up here, very low pressure. And so they can get very close to each other. Now there's a limit on how close they're getting, because there's always this these rowers are always all over the place, and there's always some rower coming in this way that'll, you know, create another little push. There's always a rower coming in this way that'll create a little push. So there's always a source of a little bit of pressure when they get very close to each other. So they never really hit each other. They just have very low pressure to a point, and then the field pressure will create enough pressure to keep them apart. So the distance between an electron and a proton can vary fairly dramatically, and the argument would be made is that physics already sort of knows that the neutron of the atom, the third particle, is basically a proton and an electron, and that you could just surmise that the difference between, say, a neutron and a hydrogen atom, because they have the same pieces in them, would just be the distance. That the hydrogen atom, the electron is much further away, and in the neutron it's much closer to the proton. Balancing the two charges, essentially. You bring this little electron closer, it has a 1 charge, the proton has a 1 charge. Obviously when they're close to each other, that could look like the two charges cancel each other out. So I probably don't need to know that either. Okay, so it can be simply understood in physics that all you have is the two kinds of rowers, shirts and skins, however you want to look at it. Two kinds of boats, boats that let shirts in, boats that reject them, you know, push them out the side of the boat. And that's it. Pushing them out the side of the boat sort of explains the two interactions. So there's only two interactions. You can either exchange, something comes in this way, you throw it back out exactly the way it came, and you change, the boat gains momentum. So that's the thing to understand, is there's an extra, what appears to be an extra bit of energy. It's not really extra at all, but you can just understand that if there's, you know, things in here, you put a new thing in, you give back something else, but you've still changed the disposition here. You know, you've replaced something going this way with something going that way, and you've made this whole big thing move because of it. You've changed its bias. So it's not a new piece of energy that makes the proton or the electron move. It's just a change in what's in the boat. So even though it seems like there's three pieces of energy, you know, there's the energy in, the energy out, and the energy of the thing moving, the electron or the proton, this energy isn't. This energy is this piece of energy that went in. It's just changed the bias of the boat. So there's the same number of swimmers, rowers. There's still the same number of rowers going this way in the universe as going this way in this reaction, even though it looks like there's more, because you made an exchange here. These two cancel out, so where did you get this extra from? Well, the extra was in the bias, that the fact that you already have it in the boat. Okay, so it already existed before this interaction happened. So there's no conservation of energy violation, even though it seems like three pieces of energy. There's really only two, and they're only exchanged. Alright, so that covers that. And so, yeah, so everything is cause and effect. Everything, waves are emergent. There's no, the randomness of the particles in the field is what it is. Now, the irony here is that the subject of drag was one of the things that was used, you know, the fact that if I have a particle moving, even a little force bit, and he's moving into a field of stuff, that it would hit more stuff forward than it would hit behind it, obviously, because this stuff, there's more of this, you know, there's more tendency for stuff to get to you quicker, and this stuff can't catch up to you because, you know, you have a common speed. So you're going to hit stuff forward, coming the opposite direction than this way. So that means more rowers go in this way than rowers go in this way if this thing is moving this way. And that would be essentially the drag argument. Now, the irony is that electrons display exactly this behavior. They clearly do decelerate. They don't have perpetual motion. So the boat, when it is moving, has a tendency, if you don't keep pumping energy behind it, if you don't keep pumping voltage behind an electron, you know, a stream of voltage, the electron stops. You put it in an experiment where you make the beam go circular, you turn the juice off, the beam isn't continue to go circular. They run out of energy, they run out of a bias in a direction because the field takes it away from them. So the more stuff they're hitting forward of them means the boat keeps slowing down and slowing down and slowing down and slowing down with each extra impact, until eventually it'll go back to just wobbling back and forth, which is the real field energy. So the more it slows down, the more it's not getting hit by extra. And so when it slows down a whole lot, it's not hitting more stuff forward than back. It ends up hitting the same amount both ways, and it just can wobble in that position. And that's its natural state. Let's say its state when it's in some field of rowers that is equally balanced, or equally balanced for a period of time. So it's a fundamental truth that there is drag, ether drag if you want to call it that. And it is what causes electrons and protons not to be, we can't make a gun that shoots them, and it's just a fact. There's no evidence that you could send a bunch of electrons to the moon, bounce them off, and receive the signal, or anything like that. So they clearly do run out of gas. And as pointed out, they also have a problem staying in one position. So as they move quite erratically, because they're moving in all three dimensions all the time. They just happen, if they're in a balanced field, that movement will just be back and forth. They'll just wobble. Alright, so that's the essence of it, so you can understand that there's a proton and an electron in a relationship, and there's another, say, electron over here. You could understand that there would be pressure between these two electrons. There would be low pressure here between the electrons and the protons, high pressure between the two electrons, and so then anytime you try to move this electron closer to the proton, that would move it closer to this electron, and that electron would find that something, there'll be more rowers that'll end up hitting the boat and end up tending to push the electron back that way. And so this is what holds atoms together, is this tension between the electrons and in their movement. Now, what a photon is just, a visible photon. It's just the probably would have been best to do the photon first, but anyway, it's just this force stuff at a specific frequency. So the electrons are what produce it, and what's basically happening is, as the electron, let's say if I accelerate an electron, I hit it, with a rower, and then I send another rower, and I send another rower, and I give it a bias of, say, 3 momentums in this direction. The field, as the electron travels, it will be traveling into a higher density of stuff going against its direction, and one by one it'll go from being a 3 bias to a 2 bias to a 1 bias, and in each one of those decelerations it's going to release. It's going to take in the rower going this way, and it's going to give back a rower going this way, to give back the momentum. And each time it does that, it's going to create a quanta. And when these quantas have the same, essentially the same frequency or distance between them, it's a photon we can see. It's a piece of energy that we call light or electromagnetic, in the sense that we can see it. So electrons decelerating from a higher velocity, that is a velocity, a tendency not to wobble but to go in one direction, a bias, where their rowers are now, they have, say, 5 rowers, 6 rowers in one direction, 6 of the rowers, 6 are going this way, and only 1 rower is going this way. So they have a high velocity in this direction, in this dimension. And they'll lose these rowers one at a time to the field, and you can sort of understand how that would be a photon. And you can also understand that that would be, frequency would be completely dependent on how much of this bias there exists. So in reality, an electron probably has 1,000,000 of these little dots, or 10,000 or 1,000, let's just say, in any one dimension. And that when you're changing this bias, the real thing that's going to indicate what the frequency is going to be is what's the rate that you're hitting things in the opposing direction. And the higher that rate, or that you're hitting them, the more often you make exchanges, and that would mean that you're releasing photons at a different time cycle. So that's the difference between ultraviolet and infrared, for example, would just be the rate of how often you're hitting an opposing rower. Now, the two things that can affect how often you're hitting an opposing rower is having a little bit of extra rowers in the ocean going this way in the field you're in, because you're in a bunch of atoms and everything else, and they've put there's a little extra bias in this direction in the field, and your velocity this way of the electron. So the two things you can change is the velocity of the electron, or how many rowers it's how dense the ocean is of rowers. So if I'm going into more rowers, I'm going to release the photon, the quanta bits, more quickly, more often. And if there's an absence of rowers in the ocean, jellyfish, whatever you want, I'm going to hit them less often, and therefore there's going to be a different time between the frequency of the photon. Alright, so to again take it one step simpler, you could understand that physics tells us, biology tells us, that we don't see light unless there's Oh, that's sort of out of the picture, isn't it? Alright. So you get the idea that that's these little quanta bits. So a photon is really a bunch of force that was ejected by an electron that obviously was moving. And this is the sign of its deceleration, is what you're seeing. Its change in direction. It was moving fast this way. It slowly got slowed down, decelerated, and this is the product, is the photon. Now, biology tells us that we can't see one of these photons unless there's 6 of these quanta. There has to be 6 of them for our eyes to register it. Now we have technical instruments that can probably recognize maybe 3 in a row. It's okay and say it's maybe a frog's eye can do that. But what we don't do is detect these little individual rowers. We don't have any instrument that can do that. So we're stuck calling this a photon. This is a minimum amount. But the truth is there is lots of rowers, and most of them, they might have an inconsistent frequency in a direction, or a row. You know, there's 2 of them close together, there's a couple farther apart, there's one over here. So there's no consistent frequency. So there's no, it's not registered as an electromagnetic event because it doesn't have enough elements in it to be registered by any of the mechanical things we have. So you could argue there's more of these broken photons, pieces of a photon, a lot more of them. And that ends up being what's called gravity. So gravity is just the rowers that aren't at a specific distance from each other in the field. And that's the pressure that creates gravity, which is squishing everything into each other, essentially. But gravity, and so I might as well. So we all know that. Well, I've explained that this is all full of this red stuff too. So the electromagnetic spectrum, the photons, is just made out of the electron energy, and electrons are more significant in the interaction with atoms because of the way atoms are made or formed, where the red stuff, the proton stuff, the positive charge, is in the center of the atom, and the electrons are on the outside. So obviously you could sort of understand that these bits interact with the world a lot more than this bit does. And that's why all of the interactions we see are usually with these bits. Now, so when 2 atoms meet each other, you can sort of understand that the protons aren't really going to be affecting each other because it's the electrons that are going to interact first. And the closer electrons get to each other, the more pressure they make. So there's obviously a very high pressure between the electrons created when they bump into each other, and they just end up pushing. This one sends more rowers into this one's electron, this one sends more rowers into this electron, going in the 2 directions, and obviously that just pushes the whole system away from this system, away from this system, based on the pressure created here, where rowers are being exchanged in exactly the opposite directions. And you can sort of understand how these interactions can change the position of the electron. It's getting a whole bunch of rowers thrown into it by the high pressure, so the electron starts moving at a velocity, and that velocity will be decelerated by drag, and by also the fact that this electron, when this one tries to move, this one's going to start throwing more rowers in this way, and so it's going to tend to push it that way, and this one's going to say go this way. So it's going to get a lot of influences that are saying go some other direction. This is going to be doing a lot of deceleration, and that deceleration will be seen as a photon eventually that might leave the electron. And that's why heat creates light, or energy escapes, is because there's a lot of exchanges and velocity taking place. But you have to put the heat in, so you have to put extra rowers into a system to get extra rowers out. And essentially that's what gravity's doing. It's pumping a lot of energy in. We're seeing it as heat, which is a lot of these boats moving, and as the boats move, they radiate heat. So it ends up equalizing, but there's stored energy in the heat of the object. Stored in the sense that there's more interactions taking place. I could argue that you could sort of understand that if there's a ping pong paddles and a ping pong ball bouncing between them, if I bring the paddles closer together, there's more interactions. Now, I didn't increase anything. I didn't make more ping pong balls. I didn't make more paddles. I just brought them closer together and I made more interactions. Interactions are what we call energy, and so I sort of increased the energy of a system just by bringing two things closer together. I didn't make more force, though. I didn't make more of it. I just changed how many interactions take place, and interactions are how we measure the energy of a system, even though it's not really correct because the quanta are the energy, but we can only measure it through certain devices of interaction. Alright, I think that's okay. Alright, so I'll take a little pause and see what else needs to be explained. But it's just this simple. Everything we see is happening because of this. It perfectly explains magnetism. I mean, just beautifully. But it also explains atoms transferring electricity, which is just transferring the pressure. The proximity problem. The closer the electrons are, the more energy they have. So atoms will expand. If you compress them, they'll tend to bounce back. This explains the whole what we see in the real world, which seems to be the fact that everything seems elastic. Everything seems to be bending, inelastic. Everything seems to be, pressure risable, and it stretches and contracts. And this explains why it does that. Very well. Completely. Really. Better than you need it as an explanation. Anyway, till momentarily. Such. Alright, so let's do magnetism. It's kind of the most dramatic thing that happens in physics, and currently still incredibly unexplained by physicists. So the idea is the magnet is essentially just made of little magnets. A lot of people understand that this big magnet is just made of a bunch of little atoms with their electron side pointing one way and their proton side pointing the other, in the sense that they're in an arrangement that has a bias, where the electrons in the atom are going this way and the protons are always a little bit behind, and so they're always behind the electrons, so to speak. And so that's what's making the atom. Now, in the regular environment, as I've pointed out, we just have a bunch of this pressure constantly around everything all the time in the universe. A ton of these little broken pieces of force. So the ones that don't have a frequency. Now, there's certainly some frequency stuff hitting us. Random photons from the universe are hitting things all the time. But the bulk of the energy is in the form of stuff that, again, the little broken pieces, the stuff that doesn't have a frequency. But anyway, it's all coming. And if you had a random field of random movement, I mean, this is for the people who really don't know much about physics, so I shouldn't be talking to them anyway. But if I randomized the field, everything in the field would sense only the universe that's coming right for us. So it would look like a reverse of a sun, let's say, where you draw the rays coming out of the sun. The stuff that hits us looks like, no matter where it came from, it looks like it's heading right for us. I mean, everything that hits us will be coming right for us in straight lines, right for us. And so everything is pressurized from all directions evenly, because basically every point in space is a point that some photon will go through, some little piece of energy will go through. So again, like I said, it just ends up being like the whole universe is pushing on you or collapsing right towards you. Now, lots of stuff isn't hitting you, and you don't see that. You only see the stuff that hits you, and the stuff that hits you looks like it's coming right for you. Well, anyway, so there's all this energy in the field. Now, people have never explained what magnets are doing, right? In the sense that magnets seem to be making energy, and that doesn't make much sense. And so, as I've pointed out, the magnet is not making anything. It's filtering this. So there's a random field of this proton and electron energy out here in the environment, and we know it affects electrons and protons inversely. So there's a ton of it out there. And what happens is each little bit is hitting this magnet. It's hitting the boats, the electrons and the protons. And what's happening inside the magnet is the tendency is to force all the exchanges will essentially mean that the red end will push out a bunch of the red and the black end will reflect the black. So you can understand that just simply as the black bits are going to reflect, the red bits are going to reflect off the red end. So even as reflections, you can understand that the energy is going to go in and it's going to look like it's coming right back out. As much energy that went into the magnet is going to be coming back out of the magnet. And that's the energy of the magnet. And the key is now it's segregated. So instead of the force being mixed, it's now segregated. I'm not spelling segregated, but it's now it's separated. And now this is going to be strongly affecting electrons. That is, it's going to repel them, obviously, because the electrons will have a reflection. So the two common ends will be highly reflective. I don't like you, lots of pressure between them. Lots of pressure between the two red ends, and the exact inverse, low pressure, between the red end and the black end. And that's exactly why magnets move. So what's moving them is essentially gravity, this outside force. The gravity that's random in its color is now being converted into something segregated, separated, and it's much more powerful as a separated force. You could sort of understand you're multiplying any kind of effect highly, because now all the red stuff is capable of hitting only red boats, and all of the black stuff is now capable of hitting only black boats. And so if I turn those two magnets around, I'll create a tremendous amount of repulsive energy because I'm magnifying the effect. I'm not wasting any ping pong balls on red paddles, and I'm not wasting any red balls on black panels. So I'm not losing anything. So you can see in this relationship, the black energy escapes. Whoops, I went the wrong way. Escapes out the black end. The red energy, so across here, it's just that low pressure I was talking about. Any red energy going into the black gets sent back out this way. So it just completely creates the two phenomenon you see in magnetism, which is very low pressure. They get pushed together by the external force, and very high pressure when they're facing their similar poles. And it just explains it all. Now, I've already explained that these field lines we see really are just the strength of the amount of the radiation coming from one end or the other end, and it's really just where another magnet lines up. So it seems kind of obvious, I shouldn't even have to point it out, but that a little red magnet would go towards the black end, the red end, and the black end would go towards the red end. In this relationship, this is a little piece of an iron filing. It's going to line up exactly opposite to the polarity of this magnet. And that another line over here would be lined up exactly the same way. Its orientation, the strong magnetic field is this one. It's reacting to this one, so it lines up this way. Now these two are the same. That means they're going to repel each other. All the red's going to reflect, and all the black's going to reflect. And that's why you have lines with nothing in between them. It's because of the same polarity. So they have to be separated. They can't smush together. So the lines are an illusion. They're not an elemental function. They're an emergent happening. And the real lines of force are these, the strength of this segregation, the strength of how much you've taken the red out of the black. So an N54 magnet would have a lot more red, and there'd be very little black mixed into this red, and an N34 would be a lot more black in the red. It would be like 60-40, 60% red and 40% black. Well, I should have wrote it in a different color, but you can get this stuff, right? You can follow along. All right. So I'll just finish with gravity and attempt to, so you understand, magnets are just filters. There's no hyperboloids in them. There's no toroids. There's no energy moving around the magnet. There's no flow of anything. All they're simply doing is taking energy in and diverting it or reflecting it. That's it. Black energy reflects off the black end. Red energy reflects off the red end. Black energy into the red end gets deflected. Red energy into the black end gets deflected. That's it. Two processes. That's it. Perfectly explains magnetism. For the first time, gives you an explanation for why there's attraction and repulsion with the same ingredients, same function. You don't have to change anything or manipulate anything or have anything bizarre happen. It's just a simple function of charge. So essentially, the electron and the proton are the magnetic monopoles. It's kind of obvious. I've been making that point. Nobody's responded at all. Nobody's given me any reason to think electrons and protons don't perfectly fit whatever the description of a monopole would be. They're clearly the source of charge in the universe and the source of the magnetic difference. All right, anyway. So gravity is a little, it's a subtle complication in the sense that it's obviously made of this same effect, this phenomenon of electrons and protons. But all you have to understand, I guess, to understand gravity is that the electrons and the protons and stuff that is not magnetic, it means that the electrons and the protons have random orientations. That means they're pointing, okay, in terms of their electron and proton side, is pointing in different directions. And so you have a whole bunch of those. Just imagine I drew a whole bunch of them. They're all pointing in different directions. So essentially there is no multiplying the effect. You have just as many electrons interacting with protons as you have protons interacting with electrons, and you have just as, so you're not maximizing the pressure by having just black things facing black things and just red things facing red things. So there's no magnetic effect. There's no polar effect. So what you really have in a non-magnetic planet, you know, it has a tiny magnetic field, very tiny. It's not even worth mentioning. It's so small, the bias in its magnetism. It's an n point, 10 to the minus 400. That's how low it is in terms of how much of the energy has been polarized. It's a very low Tesla magnet, based on its density. So very few of its atoms line up. There's a little tiny bias for, electrons at the top, the north end, and the protons at the south. Tiny bias, but only a tiny one. So basically you just have this red and black force that now has become kind of irrelevant, right? It just doesn't matter what the red and black is doing because you're already randomized here, you're randomized out here, so you've lost any polar effect. And so all you really have is this external pressure, and you have this idea of boats. So you have an idea that this pressure jumps in and the opposite pressure jumps back out. So that's still happening, essentially. And the only catch to this argument is that obviously if there's a force coming towards you, all right, it's coming, this is you, okay, and there's a force coming towards you, and I place this other object in the way, what's going to happen to that force? Well, that force is going to go this way, and this thing is going to move much slow towards you. So the force that would have got you here at 12 noon, okay, is now not going to get to you until like 6 p.m. Okay, maybe it'll get there at 6 p.m. Maybe, if it's lucky. So essentially this force has been eliminated from affecting you when it was supposed to balance the rower jumping in the boat this way. So a rower jumped in the boat this way because there was nothing in the way of this force. So the equal and opposite forces that are in the universe are happening. And what happens when there's an object in the way is it absorbs the force, moves towards you slowly, because now it has a bias in its boat, one of its little boats. So there's a whole bunch of boats inside of these gravitational objects, a whole bunch of boats. And you have a bias where the one boat's moving towards this other boat because it absorbed a piece of this force. And so you can just get the idea that obviously if this is moving towards me by absorbing this energy that was out here, the energy in the universe, equal on both sides, and it absorbed some of it, turned it into boat momentum, and by turning it into boat momentum, I'm not going to get hit by it, so I'm obviously going to start moving this way. And to move this way, I'm going to absorb more rowers going this way than this way, so I'm absorbing energy that should have hit you, and now it's not going to hit you. And so now you're going to have an absence of energy, and so that's why the objects end up moving towards each other based on how many boats they have will make them more or less effective. How dense the boats are is going to mean they can take on more rowers, and there'll be more rowers you're not going to get hit by. And so that's why it's mass related, and it's really density related, and how much density, how heavy the mass is, makes the gravity even stronger, blah blah blah. That's not really in the picture, but it doesn't matter. And so this does get subtly complicated in the sense that there's a thermal equilibrium that happens, but you could sort of understand that as these boats are moving more, that's going to create heat. As explained, heat is essentially a storage of energy in the sense it's a storage of pressure. So something already has gravity before this interaction even starts, but this interaction just cleans up. It creates as much gravity as it uses, so it gives back to the equilibrium of the system. The system, the matter's equilibrium, that is the closeness of the boats, is the pressure, and essentially this interaction won't change that. So it'll stay the same equilibrium. It's just for one period of time. At the moment it absorbs it, it'll add a little extra pressure inside the boat arena, a little extra heat, so there's a little more storage, and it'll give it back in a form that won't affect this boat. So you can sort of understand this energy goes in little tiny pieces, and what it gives back is a bigger clump of boat. So in a sense, I've made this argument previously. It's kind of an army. You can use an army example. All right. So what's really happening? I mean, the simple argument is the shadow analogy works. You can understand that there's stuff heading for something. You put a brick wall in the way. The wall moves really, really slowly. Then you're not going to feel the force until the brick wall gets all the way to you, and then you're going to feel a tremendous amount of force. All of the energy that went into moving the boat, now that's going to hit you. It's going to be released when it gets there. So obviously there's a ton of energy that's absorbed. When it finally hits you, you see that ton of energy that was absorbed. And that's the simple enough way to understand it, but this is what's kind of happening, is that the matter bit, let's see how to draw it. So you think of it as like you're fighting another army. So there's an army coming in of individual soldiers, all right, and you want to stop as many of them as possible from getting you. Well, the way to do that is to send an individual soldier to kill each soldier. Now, you could make a tank and put 10 of your soldiers in the tank, all right, and send the tank. But the problem with that is the tank can only run over. It's a steamroller, not really a tank. And so it'll wipe out these two really easy because it's 10-2. So you're going to win that, right? It's like playing war with cards or something. You're going to win that battle really easy. But all you did is you wasted 10 going this way. So now you're going to send this energy. The other 8 are going to keep going. They're not going to stop any of this force. They're just kind of wasted going that way. Okay, so they're going to go for the rest of the universe. It's like the energy coming from a galaxy billions of light years away is kind of wasted gravitational energy because it obviously didn't exchange with anything. It's escaped. Probably a bad example. Yeah, more likely to use something more complex like a helium nucleus or something. So you've wasted, 8 soldiers. So now you don't have the soldiers to fight all of this other force, so the other force ends up coming in. So the energy out, So the system takes in the energy in terms of impacts, and it gives back the energy in clumps. All right, and the clumps are very ineffective because they don't spread out, so they don't get all these extra soldiers, and they essentially waste, 10 energies here only counteracts 2 energies here, and so it's just wasting a bunch of the energy in the sense it just keeps going and going and going and going. So that's how the equilibrium is maintained, is that the energy going in is more particular, the energy coming out is clumpier, and therefore there's no longer a balance in the field. You're not effectively creating the gravitational effect. So there's more gravitational effect going in because all the energy gets in, and the clumps going out don't counteract the energy coming in, so there's an imbalance in force in versus force out in the sense that it's clumpy, and so there's an imbalance, and that's what makes stuff move. Alright, so I think that's probably enough of a video. I mean, I could go again through all of the, so let's understand, waves are emergent. There's no waves in any of this. There's just, you can have stuff at a frequency, and you want to call a bunch of stuff at a frequency a wave of soldiers or something, that's okay, but there's no fundamental or elemental wave anywhere. So everything that physics has, I can just go through their list. Time dilation is just this effect that what I've just basically explained is how heat affects these atoms. So heat affects radioactive materials. You make them hotter, their half-life reduces. So if it has a 10,000 year half-life, well, if I make it hot, 300 degrees, it has a 2,000 year half-life. Make it colder, it has a 20,000. So heat has everything to do with how the atoms metabolize, how they fall apart or stay together, and that can easily be understood. And essentially velocity is a form of heat. It's a form of cooling in the sense that instead of vibrating now the electron as you move it, as you straighten the lines, you're essentially cooling it in terms of its functions, because now it's having less interactions. Less interactions means whatever process is happening inside of an atom would slow down. So it's essentially a cryogenic effect. So there is no time dilation. You can just make things hotter or colder and make what happens to them happen quicker or slower. But there's no time dimension. It's never, there's nothing, all you can do is affect how fast processes happen by changing the momentum of things. Like you can change the frequency of light by making the electron move faster or make it move into more force. That's all there is. There is no dimension called time. Time is just a function. Time only exists because none of this stuff happens instantaneously. It takes time for the little bits to move from one place in space to another place in space, and that time is solid. It's been a constant for a long time. Okay, there's no bent space or time, and it's just silly. Obviously there is convergence in the sense that the force does look like it's heading right for me, and it looks like it's heading right for the center of me. And in the terms of effects, that's what exactly happens. We only end up with a center of gravity, because gravity is essentially just measuring our density, and the rounder you are and the more consistent you are, the more consistent your gravity will be. I would argue that just as they found with meteorites in space, if you're a weird shape, you're going to have weird shaped gravity. Fact. So gravity doesn't obey the mathematical rules unless you understand that it has to be spherical objects. And they'll all go spherical when they have enough gravity. When you have enough gravity, you crush. The pressure becomes so strong that you crush all the chemical bonds that are holding, that's creating protrusions. The protrusions are chemically sensitive, and you can break those bonds easily. So when there's enough density, you're going to break everything, and so everything will have to go round. But there's no, it's a stupid explanation of gravity. Gravity is a real force. It's the force that is actually creating the energy in magnetism. So the two things conventional physics don't explain, where the energy for gravity comes from, where the energy for magnets comes from. That's why they say virtual photon, is because they don't have any explanation for where it came from. those two are solved by just understanding it's a real force, it's not bent space. It's real stuff. Okay, there's no quantum waves. I don't know what that says, but anyway, so waves are emergent. Waves aren't elemental. There's no virtual anything. That's kind of simple. There's no electric force. Electricity is what happens between atoms and their pressure. Electricity only happens in conductors. There's no magical electrical field. The only field is this charge field. That is, you could call the red and the black force charge. And these are charged objects in a charged field. So that's all you need to understand. So charge is the elemental function. Charge has the manifestation of electricity in atoms, because the atom gets bigger and smaller, meaning the electrons go further away, meaning it looks more negative from a distance, or more positive depending on what this pressure is. So charge is the explanation for both electric and magnetic, and electric and magnetic are really the same thing. It's just about whether you're polarized significantly, or whether you're polarizing the atom itself, or whether you're dealing with the little elemental bits themselves. And so there's no entanglement. There's just no evidence for any quantum entanglement. Electrons don't know what the other electrons are doing until the force hits them. There's no reason to think that quanta, the little bits of force, connected or are in any way communicating. It's just a nonsense. No evidence really at all. The experiments are convoluted and subject to reinterpretation, clearly. What else? Obviously no need for an ether. I can't read the other ones. There's no multiverses. It's just all, the whole particle zoo is really just a force zoo. They're calling something that's moving fast. So you take the same thing and you move at one speed, they call it a muon. You can move it at another speed, it's an electron. It's just the amount of energy that's in a system. So they're just calling the same thing different things because it's in a different environment and reacts different in a different environment. Electrons don't have anything called a dipole moment, a magnetic moment as individuals. The only thing that has magnetic moments is atoms. So anyway, but yes, conventional physics hasn't got a clue really. I mean, they've gotten the two most fundamental activities in the universe, gravity, and the most interesting byproduct of gravity pressure, magnetism, and they've messed them up entirely. They just made wrong assumptions and have just wrong premises for how that works. And it's a simple error. Like I said, a lot of these physicists knew, yeah, it's got to be simpler. Feynman often, well, not often, but at least once, well, in his book also, talked about the fact that maybe it's as simple as a checkerboard. And it's just that it's so much of it that we can't see what's really happening on the board. We're just too far away. So what we see are the images that might be created on the board, but we can't see the checkers and the board. And I'm saying clearly they clearly understood that it's probably a simple mechanism, and they just couldn't think of this simple idea of just making the force also charged, just like the two elemental matter bits. Just make the force also elementally red and black, plus and minus, and now you can solve all these problems. So they just missed something really quite simple. Happens. It could happen to anybody. I really shouldn't make excuses for them, because they are despicable, arrogant assholes. They've been selling this broken theory, and they've been selling it with this freaking lie that it's the most proven theory in the history of mankind, and it's just absolute rubbish as a statement. It hasn't been proven at all. So anyway, enough of the video. Till the next time, which this really shouldn't be one. I mean, I just don't see how a rational person says, oh, you're full of crap, Gary. Oh, that's bullshit. I mean, it's 2 + 2 + 2, and it works. It wins the Occam Razor Award by a landslide. It's so simple. And it's complete. It's explaining everything we see. I mean, what else do you need? I just don't understand this resistance. It's game over. I win. You know, and the only way you can make me lose is to cheat preposterously the evidence. All right. So till next time, and such, and so forth, and whatnot. Yeah, that's enough.